Now we'll study about another important section in radioactivity, that is radioactive series. About a radioactive series, we can write when a radioactive nucleus decays into another, which is obviously when a nucleus decays into another, which is the daughter nucleus, will be relatively stable. And here we can write, and when a resulting daughter nucleus is also unstable or radioactive. It is possible that when a nucleus decays into another daughter nucleus, it will be relatively stable, but it may also be radioactive. And if it is a radioactive product, we can write it subsequently decays to another daughter nucleus, or we can call it sub-daughter nucleus, and the process continues until a stable end product appears. If we just talk about what we have written here, say if we are having an element A1, it decays to another element A2 with a decay constant lambda 1. Here the value of decay constant lambda 1 will give us an idea about the stability of A1. But somehow if the nucleus formed A2 is also radioactive, it does not achieve the stability. However, this will be more stable compared to A1. It will further decay to another element A3 with a decay constant lambda 2, and if it is again radioactive, it will decay to A4 with a decay constant lambda 3. And so on, the process continues till an element A1, which is called as stable end product, which is the stable element which is not further radioactive. Until it appears continuously, the decay process continues. Now this whole series of sequential radioactive elements we define as a radioactive series. And for this radioactive series, one thing we can say that as elements which are ahead of a previous element in the series are more stable because of the decay phenomena. Here we can see that the value of decay constant, successive decay constant in the radioactive series will be decreasing in order. Here we can write, in general, there are many exceptions we'll study later, but in general here we can write the value of lambda 1 will be more than that of lambda 2 will be more than lambda 3 and so on, because E1 is the starting element or parent nucleus of this radioactive series. So among all these elements, this is the least stable element which decays to A2, which is more stable, so its decay constant will be relatively less. So the decay constant of element E1 is maximum, that of the last element, which is lambda n minus 1, will be the minimum decay constant in the series. So you must be very careful about it. In continuation, we can also write that there are 4 radioactive series discovered, and most of the radioactive element in nature can be considered to be members of one of these series. And about these 4 radioactive series, in depth we are not going to study, but basic knowledge is required for you at your level. So I'm just giving you the idea that these 4 radioactive series have their elements with their mass numbers in the form 4n, 4n plus 1, 4n plus 2 and 4n plus 3, with n belongs to the set of integers. Let's have a look on these four series and understand what do we mean by these series with their mass number in this format which I have written here. Here you can see these are the four series which are called 4n series, 4n plus 1 series, 4n plus 1, 4n plus 3 series, which are named and the name of the parent nuclear from where the series start. These are thorium, neptunium, actinium, uranium and actinium series. So in thorium series, the parent nuclei is thorium-232, and here you can see the mass number can be expressed in form of 4n. It is only divisible by 4, so that's why it is written as 4n series. And the half-life of thorium we are given as 1.39 into 10 to the power 10 in years. And the end product of the series is lead-208. Again, all the intermediate product as well as end and parent product can be expressed their mass number in form of 4n. Similarly, a neptunium series which starts with the parent nucleus neptunium, all the mass numbers of the elements in the series can be expressed in form of 4n plus 1. Similarly for uranium and actinium series. Here we can also write one important fact that neptunium series is an artificial lab discovered series due to very short lifetime of its elements, and other three radioactive series are found in nature. Only neptunium series is the one which is laboratory discovered. You can see the half-life is compared to other series, it is very small. So elements of neptunium series are generally not found in a stable form in nature. That's why it is laboratory discovered. Rest all series elements are available in nature, and these series are naturally discovered.